Right. How's everybody doing? So, like I said, I work at Discuss. By day, I basically work on architecture, some infrastructure tools, a lot of performance and scaling stuff. And I'm going to talk about practicing continuous deployment today. I gave this talk at EuroPython, and it seemed pretty well received. I had 90 minutes to give that talk, so we'll see how this goes. So first, I want to actually describe what I mean by continuous deployment. This is kind of the de facto definition, is shipping new code as soon as it's ready. And I really want to stress what this truly means. For example, you could do this and you could ship code all the time. You continuously deploy, but that's not really what the philosophy is about. This is kind of how I treat that. So the important thing is when it's ready. What does ready mean? This is what we focus on all the time, is making it ready. This means that your code has gone through some kind of peer review process, and that's not always necessarily, and it's fairly new to us to have formal structure in place, but it's been very, very useful, and it hasn't really slowed down any of our processes. The other, and in my opinion the biggest, is passing automated tests. So this talk kind of goes hand in hand with continuous integration. Without it, none of this works at all. And some level of QA, and this might be post-QA depending on what your process looks like, but you can kind of cover your bases with just automated tests in this for the most part. So all in all, it's a focus on stability and iteration. And more importantly, it's a focus on iteration through stability. And that means you can iterate as much as you want as long as everything's stable and it's not going to cause issues. So for us, the workflow generally looks like this. I'm a developer. It's what I do every day. I commit code, right? And we try to keep this process fairly lean. We'll use all the trendy buzzwords today. So I commit code. It goes through code review. This works through a system I'll describe in a little bit. And it's basically, it's assigned to somebody. They go through, quickly review it, hopefully within 10, 15 minutes. Comes back to me. It's accepted. It's okay, great. While it's doing all that, it can run continuous integration, which just means you have a server somewhere that's running a test suite. And ideally, you've already ran some level of tests that say, my code's actually okay. You didn't just write code and it magically went somewhere. And then this integration either does one of two things. It either fails, which means we repeat this entire cycle. It goes back through commit, it goes back through code review, and generally this is where we'd revert it and send it back through this process, or it succeeds. And once it succeeds, then you can choose to deploy it. What I really want to stress is continuous deployment doesn't necessarily mean you deploy all the time, every 5 minutes. You can deploy as often or as little as you want. The important thing is that you can deploy whenever you want. So we deploy it, and then we need to rely on some kind of reporting. This reporting could literally be you clicking around and seeing if it works, or ideally it's something automated that's very powerful and can trigger very high-level alerts that will page every single ops person and get it fixed right away. And if that does happen, then you should have a very fast rollback. So with this workflow, there's some pretty bad negative things here, but the goods are amazing, right? You have very quick development, which means you can launch what product people like to call an MVP, a minimum viable product, generally very quickly. And I'll talk about how you can do that and why that's useful, but all in all, it's about releasing frequently small changes that are easier to test. And this reduces your QA time because if you're releasing, I changed the border color to red or something. If that's literally you would release every commit, you can test that easily. You look, is the border red? Okay, great. It's fine. The QA was 30 seconds. Now the bad is, actually the biggest pain point here is that it's very hard to adopt a lot of this. We've spent the last 2 years working on infrastructure, and that includes trying to improve our automated testing, trying to improve our deploy tools, our reporting. All of this takes lots and lots of time. It's in a company we're only 30 people. We actually have a guy who's more or less dedicated to dealing with tests now. We have a guy that's dedicated to releasing, and it's a very heavy task. So you have to be willing to accept the cost of this. And again, this is a philosophy, so you really have to instill this in your culture. I came from a background where we didn't do tons of testing. We would test things. A lot of it would be manual testing, which is awful. And we really had to instill all of this in us. There were some tests when I joined Discuss. There's a ton right now, and we're getting better every day. And it's just something you continually iterate on the process itself. So there's a few things that I feel are very important to implement any of this. The first one is keeping your development environment like super, super simple. This isn't just about development actually, and this is really important for several things. But more importantly, like there's several ways or several things you need to implement to do this. And first is like the automated testing. This is a requirement. Like I said, continuous integration is the basis of all of this. And now, even more importantly, like development needs to be fast. Like if it takes you a day to go through code review, or you have a daily release cycle, like you're not going to be able to iterate very quickly at all, you know? So to do this, we simplify the environment. Like we simplify it as much as possible to where we're actually still reliably writing code that's going to work. But ideally, the other systems that are much more complicated, maybe they're dedicated to this, can deal with all the processes that you haven't been running and that you haven't implemented. And another big part of this is packaging your app. Like, it's very important, and some people disagree with this philosophy. I feel like packaging your app is a must. Like whether it's a project or a library or whatever, it needs packaged. There's a number of reasons, but mostly because you need to be able to repeat whatever you're doing. Like the way you set up your local environment ideally is the same as you set up your CI environment, which is ideally the same way you deploy to a production environment. And there's many tools that do this. Some are Python specific, like Fabric and Build Out. Some are just general configuration, and that's Puppet and Chef. So this is kind of an idea. Like ours doesn't really look like this anymore because it's gotten much more complicated. But this is just an example of like your production might list all, or might have all your services, or will have all your services rather, sorry. And that'll be like Postgres, Redis, maybe you have some search engine, et cetera. It's all going to be running no matter what, right? Staging, maybe it doesn't need all that. In our example, like maybe we don't actually need the queue infrastructure because that's, you know, we have some tests that say it works no matter what. So we just scrap the queue infrastructure and we just execute those tasks in real time. That's not necessarily the best idea. Ideally, staging mimics production, but it's an acceptable thing in this case. And now our CI server, we actually dumb it down even more because like we don't need to test the full stack when we're testing our service. Like we don't care about Apache and Nginx because we assume those are going to work. We have tests that say, you know, this configuration actually works correctly, and so we actually don't need to test those ever. We just, you know, run these server-side unit tests. You know, even if we're running Selenium, we don't need any of these. We just spin up a simple Python web server. And then when we get down to like actual local development, like literally you can run Discuss with just a copy of Postgres running. Certain things won't work, but most of it will. Like the only thing that's changed since a year ago when I initially started some of these slides is that we just now need Redis for most things that happen locally. So how do we look at this? Like for us, we want local to be dead simple, and for us, it's you clone a repository, which is we're kind of a monolithic app, but we have been splitting it into smaller services. So let's say this is our monolithic app. We clone this, pull it down, and ideally you just run a command. That's like make, or it's build out bootstrap, or whatever it is. It's a simple command that should just take care of everything. And this is not the same as pip install. It should run pip install for you, or Python setup.py develop, or whatever it is. It should do that for you. And then you spin up whatever the service is, whether like, in this case we use Django and we run run server, or it could be, you know, Flask and you just call the app and it runs workzog, or anything along these lines. Just keep it dead simple. And now what's even more important, and like we're slowly shifting to this more, is like, if you need to test these other things, have them available. Like it shouldn't be impossible to set up Rabbit locally. It shouldn't be impossible to have Postgres and Memcache and everything else running on the correct dependencies. So like, what I really want to instill in you guys, and we're still working on this, is run the services through something like Vagrant. It's super easy. You can just configure it with the same system you're configuring production. You can have all these hard, complicated to install packages all configured almost the same as they would be in production, and it makes it so much simpler for the developer, which is all you should really care about. So once we've simplified kind of how we can develop and what, like, we actually need to figure out how we can, you know, roll out features, because it's not just like you can implement a big feature, deploy it, and it's going to work. Like especially once you're scaling things out. We at Discuss we do, I think, on a low level like 12 to 15,000 requests a second. This is an everyday number. It's always around this. We peak much higher than that. So it's very important that if we release a feature, like it doesn't take down the website. If it executes some bad query, we need to know that, you know, ideally it's been reviewed ahead of time and it's okay, but things always happen. Things are always going to happen. And in this case, we want to like slowly release features. And we do this through something called feature flippers, or as we like to call them, switches, because I feel like it's kind of more obvious in the testing environment. But we have a platform we built called Gargoyle. It's very Django specific, but we're actually working on rewriting it right now to be at least Django agnostic, but ideally platform agnostic, so it can run on multiple languages just through some shared protocol. And it's basically like you have a new feature. A good example in Discuss is we have this comment widget, and it has a real-time feature. So like maybe we're just releasing real-time. So it's behind this switch, and it literally says, looks something like this, if the switch is enabled, use real-time. If it's not, don't use real-time. So what we do is we go back to this interface here, and we can like specify some conditions. So what we might do at first is we say, I'm only going to enable this for people who work at Discuss. And then we can kind of flesh out things internally. And then from there, we might say, OK, everything's looking good. Let's turn it on for 1%, because that gets a sample of real traffic. From there, we just bump it up as we see fit until we know that capacity isn't an issue. And we've done a couple things. Or we've used this in a couple ways that have been super useful. Like we have an early adopters flag for everybody that signs up, and that you tick a box, and you now opt in to us breaking things on you, which doesn't generally happen. But it makes it a very nice way to initially test like with some audience that are willing to accept some issues. And also going back to this real-time example, let's say it was on 100%, we may not remove that switch. Like even if the code's used everywhere, what if it's relying on a service or something, and like we haven't implemented proper infrastructure to degrade this yet. We can like, oh, there's a problem with real time? Well, let's turn it off. And I actually took down Discuss for about maybe 10 seconds the other day by turning on a switch, and it was back completely green 10 seconds later by just literally clicking a button on the website. If you don't have Django or anything like this, like logic is very, very simple. For example, you might take like an integer representation of the IP address and just say, 50% of these integers are going to be enabled, and that's how I take a 50% use rate for a switch. So the second thing, which is really important after we actually write the code, is going to code review. And we actually require that everything go through code review at this point. And we do this using a tool called Fabricator. This was written by Facebook and open sourced. I feel like it's been a little while now, but I'm not entirely sure the date. And we just adopted this in the last 3 months or so. Really amazing tool for code review. It's written in PHP. You'll have to live with it. It's very, very good PHP. But it kind of looks like this. So it's like a bug tracker, sort of. You're going to see a code review. In this case, it's one that's actually completed. And it's gone through, like, I'm requesting review. This guy's gotten the notification. He's left a comment, which isn't really important, because if it was, he'd request changes, and this would go back to a different state. But he says, this is OK, but we might want to rethink doing this. And then we close it out, and we accept it, and it gets merged in. Now, what's really, really cool about this tool is how you use it as a developer. This is a nice web interface. It's great. You don't actually have to use it for almost any task. For example, when I'm opening a code review, all I'm doing is making a commit. I'm making a commit that has all of this metadata in it. For example, it has the summary, the title, kind of generic Git stuff. You can also assign reviewers here. You can reference tasks, which manifest is their name for a bug tracker. The names are a little odd. Differential is the name for their the review part of it. So in this case, we've specified everything. The differential revision actually gets specified later. This is a fully closed out ticket and what it looks like in the commit log after it's been amended. But I just commit this code in a branch, and I run a command arcdiff. And what arcdiff does is it runs, based on your configuration, a set of lints. So for us, this is actually upstream now. You can just configure it to use a standard linter. It will lint Python files. It will lint PHP, JavaScript, basically anything they support. And what's even more cool is like the way we've done testing with this. For example, in this case, like we've made a change and it affects something in this Discuss authx thing. And specifically, this is not our entire test suite. This is only tests that it's detected that it needs to run. And this is surprisingly simple to do. We tried a very complicated way of like measuring tests and tracking what was actually executing what and making this all magical. It turns out it's much easier if you just say, your tests go in this directory, which matches where the code is. So in this case, we probably modified this test file so it knows to run it. And we've actually cropped this. There's some other stuff. But you can actually do this super, super easily. Like we use Node to do this, and we've released a plugin that I do not have listed in here called Quick Unit, which is super easy to configure. You just have to adopt something, honestly, of a more standard testing policy that's used across other languages as well. Anyways, so everything passes. It shows that some of our tests are awful. They're all slow. And then it says, okay, great, I'm going to upload this differential, which is uploading it to the code review tool. Now this other guy's been notified, he's going through it, and I'll get notified when it's okay. And when it's done, all we do is type arc land and then the branch name. And it does all the magic and amends the commit message so it looks like this with the actual revision name. And if there were any changes in the ticket, like via the web interface, it'll update them here as well. And it merges it in and it pushes it upstream. And now once that's done, and potentially at the same time, we don't do this yet, once that's done, you run integration. And we use Jenkins for this. It's super easy to set up. If you want any kind of integration, just use this. All you have to do is write a simple script that tells it how to run your tests. If you use nose, you just tell it to dump XUnit results, and you dump them in this location, and it magically reports. And it's very nice and easy to go. It kind of looks like this. In this case, we have a failed build. It tells us what's failed, gives us a very little bit of information, but more importantly, it notifies us at the bottom, and this is via the IRC integration. So when we were actually deciding on what we needed, we had to think of what are requirements for integration, what actually matters. First and foremost, you must know when something's broken, when you've broken the build, and ideally you run your tests, but maybe there's this crazy integration test that tests everything and you didn't think about this condition. So you must know right away that you did that. And it's important to know right away because as soon as you have to context switch back, if it takes 40 minutes, you've already started on something else. And now you have to be like, oh no, this feature that I thought was done is broken. I have to finish this now and I have to go back and I have to redo everything, right? So it's important that it does that. And Jenkins has plugins for everything you can imagine. IRC email's built in. It has instant messenger plugins and it works very well. It also needs proper reporting, and I really mean just integration with proper reporting. There's plugins for all of this. For example, XUnit, like I was saying with nose, lint results, it can parse pylint or pyflakes results. It can also parse coverage.py results, and it's super useful for these things. And it's very, very easy to use. We talked about some things around WAR files at the Web Summit the other day and how they're interesting and whatnot. Jenkins is literally, you can pull down the file and do java-jar jenkins.war, and it will work. Or you can just add the source in apt-get install. So now, it's great and all, but there are issues with integration. These are kind of the big pain points we've seen. First and foremost is false positives. Either the reporting isn't accurate because the test suite didn't run correctly, and now it's just saying some weird test failed. Or a third-party service is not responding, and we had a test for that. Or even worse, you have a bad test. For example, we had something that wasn't taking time zones into account or something, and it would fail at 6 p.m. every day. And this is just you make a change at 6 p.m. This is unrelated to your code, and now all of a sudden the build's failing, and you're like, what's going on? So that causes a lot of issues, and it wastes time, right? Test coverage is another big one. We've kind of fought with this for a while, how do we get better coverage? We had decent coverage when I joined, but we wanted more. We always wanted to improve it. So we have a lot of issues with regressions on untested code, and that's a problem you're going to see all the time. And we have this issue with delay of feedback. And like I said, if the test suite takes 40 minutes, it's 40 minutes later until you actually know that what you did earlier is causing a problem. So a little bit of what we've done to kind of solve some of these, or what you could do rather. So a false positive might be that the test fails at 6 p.m. every day. So just rerun the test and see if it fails again. This goes hand in hand with report on that failing test. Don't just rerun it every day because it always fails. Make sure whoever wrote the test fixes it somehow. And if you are testing external services, you can do that differently. In your normal test suite, you should be mocking things or somehow faking the service. In another test suite, which can run slower and maybe once a day or something, you can actually test if that service is actually generating the response you were expecting to begin with. The second issue is our coverage. How do we get more tests? So I think the coolest thing you can do with this is when you commit code that isn't covered, right away. You might be just touching a minor feature saying, oh, you know what? I don't want the switch to be on anymore or something. And maybe for whatever reason you have some kind of syntax error that your linter and anything else didn't catch and you didn't have any tests. But how do you know that your minor change, which shouldn't be introducing new behavior, is actually causing something to fail? And if you commit code, if you add code or anything, if the coverage dropped, that means you added new code that has is untested. So if you want to maintain high coverage, you could literally fail the build when somebody commits untested code. And you can also do this other ways. By just measuring the coverage when you actually submit the code. And we do this as well with Fabricator, which is actually kind of neat. And it will actually give you kind of a report that's somewhat accurate. that says, this code actually had no coverage at all. And it will be like, your diff has 44% coverage. And you can also do that with this nose plugin I was talking about, which is quick unit. And then code review. Again, this is super important. Like, if you submit something and I see that it's, it's fixing a bug, and I don't see a regression test to go with that, then I can reject it. And I can say, we need this. We need to improve our coverage, right? And I think that is going to be the easiest way for anybody to get started with this. So speeding up the test. This is by far where almost all of our time has gone. When I started, our test suite was much smaller than it is now, maybe rough number 60% of what it is now. And it took 40 minutes or something like that, and eventually it took an hour. We kept adding tests. They were super easy. We just added integration tests. A request comes in, and we want to test what if, page number was A instead of 1. So let's have a request come in, do all these database queries, and see if it errors or if it returns, some other page. But all we really wanted to do was test if it was validating if A should be a number or not. So early on, we were writing a ton of integration tests. Django made it super easy. Not necessarily a good thing, but it is easy to get started with. So start by writing some unit tests. Don't replace your integration tests. We did that in a couple cases, and we were writing so much mocked code that we were returning responses that to us we wanted to be valid, but the actual, say the cache, wouldn't actually return a response for. So be very careful with what you do in unit versus integration. Mock external services, like I said before, swap them out with, you can use the mock library, it's amazing. You can monkey patch URL-lib or something and have it return a response. So it actually doesn't have to connect to the internet. And you can have some other test over here that actually connects to whatever this service is and make sure it's playing nicely. And by far our biggest win, and that we wasted a lot of time on, and eventually came up with the dumbest solution that works amazingly, is distributing tests. So a while back, we were trying to build something that would automatically be like, oh, I have all these test classes. Let's just distribute those in a queue or something to make magic happen. Turns out it was much easier just to write a simple matrix in Jenkins, which basically is us somehow listing every single, actually, a better way to describe it is we partition the test suite manually, and we just submit this list to Jenkins, and our test suite was up to an hour at one point. It now takes less than 3 minutes, I believe, to run on our cluster of 16 Jenkins servers. Which actually only might be 2 machines or something. And it was super easy to implement. We wasted a lot of time, and we didn't take the dumb solution, which really, really made a difference. For what it's worth, our test suite is actually only 12 minutes without distribution. So it's not too bad now. It's definitely improved a lot. So the final piece, and that's super important, is reporting. Why is reporting important? I've had a lot of places where I've asked these kind of questions. I'm like, hey, what happened to this server? And the other guy's like, oh, is it not up? And that, I mean, you should be embarrassed if you ever ask that question. You should know that it wasn't up to begin with. So I think it's super important to record meaningful metrics. And we do a decent job at this point. Our ops guys get paged around the clock all the time for crazy things. And just to give you an idea of the things I think are important, and we've instilled a lot of these, rate of traffic is super important, right? If all of a sudden you're getting half the number of requests a second, something's probably wrong. But it's not just how many pages are people loading on your site, but how many users are being created on your site. In our case, how many comments are being created. If there's a bug in a specific area that wasn't caught, we might see one of these drop and instantly we'll know there's something wrong, and then we get a rollback, and we roll back right away. And it's better to just roll back and then figure it out rather than sitting there I wonder if something's actually broken. So it goes to business versus system logics. Are your users registering? Are you generating revenue? Versus does this database server have disk space? Or is it using too much CPU, or is it out of memory, right? You need all of those. Response times are something else we've just been starting to track better. We've had them in our system for a while, but we've never really measured success. And I think it's super important to have that, because if your response time increases by 20%, and this wasn't expected, and you release the feature to 100% of your audience, that could be a huge impact. And this, again, just isn't web. It goes down to your database. How long does it take to connect to your database servers? That's important. And also, simple things like exceptions. Those are the obvious ones, right? And most importantly, if you're not doing this, monitor social media. I think half of our support's time, or maybe even more, is just spent on replying to Twitter and deciding if things on Twitter are valid or not and sending it our way. And it's super, super useful. So there's a couple tools we use beyond things like Nagios, which notify you, and we use PagerDuty, which notifies you. So ignoring those kind of things, how we collect these is what I want to focus on. And the first is Graphite. maybe not the best slide for this. It looks way better most of the time. But it basically lets you say, here's my metric, increment it, or here's my metric, set the value to this. And you can basically do any kind of logic you want in here. We send our response times here, we send our counters here, we send disk space usage here. It has a ton of functions so that you can actually transform this data on the fly, and if you can't, you can transform it before you send it here. And if you're actually interested in some easy ways to collect this, we have a project written by a Ruby guy, so don't mind the Python code, on GitHub called Porkchop, which is pretty good at sending some system metrics. And then the second thing, which we built in-house, is called Sentry. And I might have demoed this last year a little bit, but I'm really happy to say this year you can actually use it if you're not using Django. And it basically aggregates errors. You plug it into your framework or your application, whatever it is, you say, you know, whenever there's an exception, send it here. And it will magically do all this stuff to figure out what the exception looks like, what data is important, does it like already exist in the system. And in this case, we have like 4 exceptions. You know, this one's been seen, what is that, almost 80,000 times, which is definitely not unheard of for us. We had something in the millions. And they're generally things that it's just like, well, this actually isn't important, but sometimes it errors because people send invalid data. But it's important to actually know that these exist. And I almost want to say we get just as much usage out of our graphs and our actual like automated metrics as we do the ops guys just watching this whenever they deploy. So to kind of wrap up what I'm trying to go with here is, actually, I wanted to point out how I didn't talk about deployment first, mostly to cut down the time of this talk, but because I think it's the least important part of continuous deployment. Everybody solves it differently. It doesn't really matter what you do. You can do the cron job that pulls from a branch every 5 minutes if it exists. I mean, that's fine, sure. I wouldn't recommend it. The way we do it, just a quick overview, is we take a virtual env. It's relocatable, we compile things, we ship it as a tarball to the servers, and it makes for a super fast and scalable deploy. But you can literally just have, you know, I'm gonna git pull on my machine, or I'm gonna, you know, create a release here, which is very common, which is like a git sha, and it just symlinks to another directory, which is like your current repo, and then you can just swap over that symlink, and you now have a new version live. But like I said, the least important part of continuous deployment is actually how you deploy the code. So to wrap some of this up, the things I would highly suggest getting started, or if you don't do it today, do it either way. Packaging your app is important. Like whether this is officially through setup.py and requirements and all these like nice little Python things, or if it's you prefer using Debian packages in addition to this possibly, or on its own, or if you do what we do and you create a virtual env and you tar it up and you just ship it everywhere. There's many ways you can package it, but you should definitely package it. And this goes back to making everything consistent, reliable, and repeatable. You know, your system should look like your CI server. Your CI server should somewhat resemble your development environment. And you can make this really easy by just shipping the same thing to your CI server that you would ship to production. In our case, we actually have a build that says, okay, CI server, you passed tests, now create a release. So we can just ship that as soon as we're ready. Value in code review is something we didn't do for a long time. We've implemented this, I think, fairly well in the last few months, and it's super, super useful. The amount of like feedback that you get that you would never consider, or even if you don't care about it. Like you get feedback that's really, really valuable, and it takes very little time. Most importantly, you know, deploy however you want, but make it so you can roll back very quickly. Generally, like if you're using the symlink approach, which is very common, or you have a tarball or something, you probably have like a list of releases. Just swap the symlink to the old release. And set up automated testing. If you don't have integration, you should have it right now. It's very easy to set up. It costs you nothing unless you have no tests, and then, I mean, you're in for a world of trouble already. And gather metrics. Like, start with something easy. Start with, you know, how many requests am I getting in? Add more advanced things. Like we just recently added how many writes and updates and deletes per second is each database server getting. And not only is it just each database server, it's every single table on each database server. So we can actually see, you know, what's causing us the most pain on this database cluster. Can we move it? Can we do these other things? And it helps us kind of determine problems a lot easier. And if you want to be a little bit edgy, you can go a little bit further. And we haven't done some of this. An immune system is something a lot of people talk about, and it's something that automatically, in most cases, it would automatically roll back if it like detects maybe you lose 50% of your registrations per second. It's a really cool idea, but it's also very risky. You have to be very, very confident in your system to do this. You can also automate deploys. It could work. I think it could work just fine, but I truly believe continuous deployment doesn't just mean deploying all the time. It means deploying whenever you want. Hopefully that's all the time. Like adjusting it to your culture is very hard. Like we've iterated on this over and over and over, and there's this like spiel about the right way to do things. You don't have to do it a specific way. Adopt what things make sense for you and go from there. And SOA is where we're heading, and we've started in some areas, and it makes this much easier. When you can isolate services, just test those services, just deploy those services, have all of these great processes, and just implement them per service, and deploy a single service. And you know when that service breaks, it's compatible, just roll back that service. You can still deploy this other service, which means in the end, that as a developer, you can just keep committing code, you can keep writing code, and you're not wasting time like worrying about like, oh, is it gonna affect this, is it gonna affect this, unless it actually does, and then you can deal with it. And that's about all I had. Questions?
Hey, so for code review, your tools, you said you've been using, I can't remember what the name of it is.
Fabricator.
Fabricator for 3 months or so. So what made you decide to use that tool, and what were you using before, and yeah.
Before Fabricator, we were using pull requests, and I know there's some GitHub people here. I have no idea how you scale this with the number of employees you have. Maybe there's a way. We couldn't figure it out. We used pull requests for a long time. I still use that heavily in open source. Send me a pull request, I'll review it. I generally am not as rigid as I am with Discuss, but at Discuss we're very rigid, and we want, you know, if there's an issue, we reject it right away. And you can do all this with GitHub, but it wasn't structured enough, and we had issues with like, oh God, my feed's full of all this stuff. What am I supposed to look at? And it worked for a while. We wanted something more rigid. And we looked at various things, Fabricator being one of them. We looked at whatever Google's thing is. I don't remember if it wasn't Git compatible or if there was some other reason we didn't choose it. But Fabricator was really good. The guys that maintain it are awesome. They have implemented a ton of stuff very quickly for us. Highly recommend it. But it just seemed like the right choice for the job, and it was just that we really wanted more structure at that time.
Okay. I have one other question too. You mentioned you guys use Selenium tests, right?
Right.
Okay, so what's your process for that? Do you have Selenium tests that run on the development box?
We deleted all Selenium tests. We have replaced, so we're re-implementing some, but we had all these slow, ugly, always Selenium tests that were not useful at all. We deleted all of that. We're trying to implement JavaScript unit testing correctly from the get-go to some extent, but we're also implementing new Selenium tests that are just like very, very basic. Does it work from here to here, period. It can take a little bit longer. It'll run in parallel with everything else, and we have like, you know, maybe 5 of them or something. We don't need to test like every single thing, you know, like does this button exist? Can you click it? We just want to know like, does the comment form rendered? Can you post a comment? And like simple integration tests that matter. Because yeah, Selenium it is painful to use. Yeah. Like there's a lot of stuff you have to be careful with.
I never met somebody who's been 100% like, yes, everything works perfectly and we love Selenium.
We tried very hard for what it's worth.
Hey, how's it going?
Hey.
So I was just wondering, how many times a day do you guys deploy at Discuss?
And as many as we want. At minimum, we deploy once a day to clean slate. But it's generally like we deploy if we want to deploy. It's not the greatest thing. Like ideally, we would deploy after every commit because then the QA level is small. Like the risk is smaller, right?
Yep.
We don't do that because it does take an amount of effort to deploy at our scale. Like it's not simply just get pull and things work and restart a single server. It's that, you know, you have to release this to a ton of nodes. Usually there's like some kind of order because maybe this relies on this still too much, which is a problem on our end, but it's what affects our deploy times. We deploy as little as once a day. Lately, it's no more than like half a dozen times a day. But that's not because we couldn't deploy. It's just that like we haven't seen the value in continually deploying that fast.
Gotcha. Well, it's good that you recognize the weaknesses.
Like I said, all of this I think is a grain of salt and adopt it to your own culture. Right. You don't have to live any of this by like a gospel or anything.
Okay. Also, one more quick question: Why do you roll back? Why don't you fix it and move forward and kind of give that aura of continually progressing? You know what I mean?
Yeah, it might not be quick to fix a lot of the times. Like generally when something breaks, we want to go back through this process so we make sure it's not broken again. So we want them to have to like, we want to revert that commit. We want them to be like, you know, this was broken, commit it again, go through review again, go through test again, make sure there's coverage for what just broke, and then we'll deploy it again.
Right. Okay.
So it slows it down a lot, but it makes it much more stable.
Yeah, without having a massive amount of coverage, 98%, I can understand that.
Right.
All right, thanks.
Thank you for the interesting talk. what do you all do about like database changes? Like, especially for rollback, like eventually you have to make persistence changes, and that means saying you're sorry.
Right. So I deleted my simple schema changes slide. If you Google like scaling schema changes or something, or scaling DDL, like there's a post on my blog, but you always make backwards and forwards compatible changes. So it generally means like you, in our case, maybe you add a column to a table, it's nullable. It doesn't need to exist right now, but it's there. Now you've added the column, now you somehow commit the changes that need to backfill that column. So like if the data actually needs to exist at time of like code change, right? You backfill the data, and then you commit again, and you have whatever actually needs to use that data. And ideally, this is behind a feature switch, so if somehow that data is messed up, you just turn it off and you restart the process. But we never would go back and like drop a column or anything like that. Like, we're very careful about schema changes and things like that, because like you don't just make them on a whim. You have to actually consider the impact of what you're doing and what it means long term to some extent. And I think it's fairly easy, but like Google that blog post, discuss scaling schema changes, or my name, something like that. It's on my blog, and it basically describes the process we use. And it goes into much more detail than I can right now.
Okay, thank you.
Do you have any code review policies, like a maximum number of lines, the recommended time to get your review back to a person?
We're trying to implement policies for like, you need to have this reviewed in X time. It's still a struggle for us, honestly. We haven't found a good thing yet that makes this work. We're at least right now saying, at the very least, at the start of the day and the end of the day, you should clean your slate. That really sucks, because then you might have to wait a day for a review, but usually like if it matters and it doesn't need to go out right now, again, we've been fairly stable with changes, so it's not a big like we want to release today, it's we want to release as soon as we can. So it's just, please review it quickly. If it takes you a little longer, that's fine. Ideally, you would say, if you can't review this in the next 20 minutes, we assign it to somebody else and they review it, right?
Really, 20 minutes is like your
I think that's reasonable, because like
Wow.
you have to context switch to go back and change it if there are changes.
But you're kind of asking for a context switch of the reviewer.
Right,
as well.
exactly. And that's the idea, is that, there is going to be this allotted time where you're going to have to deal with a secondary context, right? And if you can't actually switch, but you can skim something, I feel like that's fine. If I can just quickly be like, can't do this right now. And then I can just go back to what I'm doing, and I shouldn't really lose much focus. Versus, oh, maybe they'll get to it by the end of the day. I don't even know if they're going to get to it. And that's our big issue that we're trying to solve right now.
Okay, thanks.
Hi. Can you share some numbers with us, like production hits, like how many servers?
We have, I believe, less than 200 physical machines. Like I said, on average, I think we do between 12 and 15,000 requests a second to non-CDN servers. We peak much, much, much higher than that. I can share numbers that we kind of just recently announced. We just hit 700 million unique visitors across our network sometime in the last month. 4 billion page views, massive amount of traffic every way you look at it. But outside that, I don't really have any more numbers on hand.
So how long does it take to deploy anything to production?
We're working on this as well. It was slow last I heard. For some reason, it took quite a while the other day. I'm a little bit ashamed to say how long that was, so I'm not going to. But we are improving that, and this is where I go back to SOA. Like, if it's a smaller amount of machines you have to deploy to, you can deploy quicker. If something's not relying on those machines as heavily because they're not doing many, many things, maybe you can deploy them much quicker. So right now, we're working on speeding up the deploy process. One of those is, like, we actually just did this tarball change very recently. Trying to remove some of the warm-up time from like Apache, so we can actually deploy maybe like 2 times as fast or 3 or 4 times as fast. But unfortunately, we haven't scaled the speed of deploy as much as we'd like with the number of servers increasing.
Do you guys have any geolocated servers, or
all of our servers are based in one area? We use Akamai as a CDN, and we push a lot of stuff to the CDN. And that's actually like our crazy optimization for making everything fast.
All right. Yeah. Thanks.
Hello. I was wondering, when you do a deployment, is that one deployment across all different types of boxes, or is it sort of like, okay, we're going to deploy all the app servers now, but that's not a deployment for the whole stack? And if so, how do you manage shipping the tarballs? Is it one big tarball that boxes just take a piece of, or are there many that stay in lockstep?
Right. So like I said, we're moving to SOA, and we've actually started with that. For example, our comment widget is specifically a service called embed. We can deploy to that and not deploy to anything else. We can deploy to our RESTful API and not deploy to anything else. We can update our importing tools and not deploy to anything else. So that's how we've kind of taken care of, like, because you can't do the monolithic deploy forever. That said, like, however, there are like the embed and like the API, specifically the embed, and maybe there's another one that's not API, is a fairly large amount of servers. It's not ridiculous amounts. Like I said, we have less than 200 machines, and most of them are not web servers. But that's how we're dealing with that, is just by splitting them up into services. Whether it's the same application or not, it doesn't really matter. It's just that they run configured differently, or they run different versions of the code, rather.
Thanks.
Sorry, time for one more question.
Could you tell us about your rollback process?
I'm actually not sure what it is at this point. I know at one point it was literally just swap the symlink, restart the server. It would take less than a minute to restart every single service on every server for this, but that's all it is.
I want to ask about the business metrics measurements. You sort of skimmed over it, but did you have to write your own tools for that are applicable to your business, or were you able to leverage some of third-party tools for something?
Like I said, we use Graphite, and we just write a statsd. When an object is created, we just write a statsd. Like, we implemented a majority of this. System metrics you can get like via the thing I was talking about, pork chop or something else, but the business metrics, it's hard to have a generic tool for a lot of those, unless it's something common like PayPal billing or something like that. But everything else, it kind of gets into specifics a lot of the time. All right, thank you guys.
Thank you very much, David.